Imagine like a massive, impenetrable bank vault. You've got a 3-foot thick steel door, state-of-the-art retinal scanners, heavily armed guards at every single entrance.
Right, the whole 9 yards.
Yeah, exactly. But inside the vault, the money isn't locked in individual safe deposit boxes. It's just sitting in these massive disorganized piles all over the floor.
Out in the open.
Just out in the open. Anyone who manages to sneak past that imposing front door can just grab a bag, stuff their pockets, and wander freely from pile to pile without anyone batting an eye. And for a long time, that was exactly how our digital security worked.
It really was.
Welcome, everyone, to the WeCyberYou Unlocked podcast. I'm thrilled to have you here with us today. Before we jump into things, do me a massive favor, hit that follow button on the channel, and make sure you visit WeCyberYou.com for a ton of other great content just like this. You won't regret it.
Glad to be here with you. We definitely have a lot of complex ground to cover today.
We really do. So let's get right into the mission for today's deep dive. We're looking at a topic that sounds highly technical on the surface, but it dictates the security of almost everything you do online. We are talking about virtual firewalls and securing dynamic cloud infrastructures.
It's a huge topic.
Huge. Our mission today is to explore exactly why those old-school, heavy physical firewalls you might be used to hearing about, the big metal boxes blinking in a server room, why they're completely obsolete for modern networks. We want to understand how software-based security is adapting to guard our scattered, highly complex digital lives.
And to set the stage for you, the listener, the stakes here are astronomical. Today's organizations, the companies holding your personal data, your financial records, your healthcare history, they aren't operating in static, predictable networks anymore.
Right.
We're living in a world of public and hybrid clouds. We have virtual data centers, entirely remote workforces, and containerized apps. And for those who might not be deep in the dev world, containerized apps are basically lightweight packages of software code that can run consistently on any computing environment. Right, like you can pick them up and move them instantly.
Exactly. The old physical perimeter is entirely gone because the infrastructure itself is constantly shifting. Because of that, security can no longer be tied to a physical location in some corporate basement. It absolutely must follow the workload wherever that workload goes.
Okay, let's unpack this. Because to really grasp where we're going with these virtual firewalls, we have to acknowledge the historical shift from hardware to software. Look, if you're listening to this, you probably already know the era of the physical perimeter is dead.
Oh, completely.
For decades, organizations relied on a dedicated physical appliance sitting right at the edge of their network. It was basically a giant, intimidating bouncer at the front door of an exclusive nightclub.
Yeah, the bouncer analogy works really well for the perimeter. But to be technically accurate about what went wrong, you have to look at what happens inside the club.
Right.
If you made it past that bouncer, whether you had a VIP pass or you just snuck in through a back alley, you had free reign. Nobody's checking your ID at the bar. Nobody stopped you from walking into the DJ booth. The perimeter was secure, but the inside was a total free-for-all.
And modern infrastructures basically took that nightclub and blew it up. Workloads move dynamically now. Employees log in from coffee shops halfway across the world. Applications run across multiple different clouds like AWS or Azure. And infrastructure spins up and shuts down in a matter of minutes based on user demand. A physical bouncer at a single front door is totally useless if the nightclub suddenly has 1,000 doors that are constantly changing locations.
Which brings us to a massive shift in how data actually moves. The core concept to grasp here from our sources is the difference between north-south and east-west traffic.
Okay.
Those traditional physical firewalls were entirely focused on north-south traffic.
Meaning data entering or leaving the network. Like picture it on a map traffic coming down from the public internet into the corporate network or going up from the internal network out to the internet.
Correct. But modern cyber attacks don't just stop at the front door. The real damage happens when they exploit what we call east-west traffic.
Okay, east-west.
Yeah, this is the communication happening between internal systems. Server A talking to server B inside the data center.
Let me push back and clarify this for you, because understanding this mechanism is a big deal. Say an attacker breaches one minor internal system. Let's say it's, an internal HR portal for submitting PTO requests.
Yeah.
It doesn't hold the company's deepest secrets, so maybe the security's a little lax, and an attacker gets in through a phishing email. If an organization doesn't have a virtual firewall watching that specific internal east-west traffic, that attacker can just quietly move laterally over to a highly sensitive financial database.
Yep.
And they do this without ever crossing that main perimeter firewall again.
That lateral movement is exactly how massive, headline-making data breaches happen. Once the attacker is inside that low-level HR server, they start mapping the internal network.
Wow.
If the internal traffic isn't being actively inspected, they just hop from server to server until they find the crown jewels. This internal east-west communication happens at incredibly high speeds in modern data centers. A traditional firewall sitting at the network edge has absolutely zero visibility into it because the traffic never goes out to the edge.
So they're basically crawling through the air ducts, and the security guard at the front desk has no idea.
Exactly.
Which is exactly why we need a new approach. So let's lift the hood and figure out what is actually going on here. What are virtual firewalls actually doing differently?
Well, a virtual firewall gives you all the traditional firewall capabilities, traffic filtering, access control, intrusion prevention, but it does it entirely as software within a virtualized, cloud, or software-defined environment. No physical hardware required. It runs directly on cloud platforms or on hypervisors.
Hypervisors being the software layer that creates and runs virtual machines. So no metal boxes, just pure code doing the heavy lifting.
Right.
Instead of just listing off features, let's trace the journey of a single piece of data to see how this invisible guardian actually operates. Say a cloud workload sends a request to a database. In the old days, that request might have to travel all the way out to a central physical firewall and back. How does the virtual firewall handle it?
It intercepts the chatter right there on the spot. Because the virtual firewall is embedded in the software layer itself, it grabs that traffic instantly as soon as it leaves the virtual machine. That is the first crucial phase, traffic interception.
Okay, so it intercepts it.
Yeah. But it doesn't just look at the basic IP address to decide if it's safe. It immediately moves into step 2, which is traffic classification.
Right, because an IP address doesn't give you the full context. It's looking way deeper to identify the specific application, the user identity, or the device context. It's asking, is this Bob from accounting using his company-issued laptop, or is this an unknown device connecting from a strange location?
It's all about context. And once it knows who is talking, it performs stateful inspection. The virtual firewall maintains a constant awareness of the active connection. It tracks exactly who initiated the handshake, whether the response makes sense, and most importantly, if the behavior suddenly changes mid-session. It prevents an attacker from hijacking a legitimate session that's already been approved.
Okay, so if the firewall knows who I am and it's tracking the connection, is it also looking at what I'm actually sending? Because if I'm an attacker, I might have stolen Bob's credentials. The context looks right, the connection looks right, but I'm trying to send a malicious file.
And that's where we hit step 4, deep packet inspection.
Here's where it gets really interesting.
It really does. The virtual firewall isn't just looking at the envelope to see the return address anymore. It's actually opening the digital letter and reading the contents. It actively searches for malware signatures, suspicious commands, and exploit attempts hidden deep inside the data packets.
But hold on, if it's constantly tracking these connections and opening every single digital letter, isn't that a massive drag on computing power? Like, how does it actually look inside the data without grinding the whole network to a halt?
It's a great question because deep packet inspection is incredibly computationally intensive. Virtual firewalls handle this by heavily optimizing their code to utilize multiple CPU cores in parallel.
Oh, I see.
Plus, they often only perform this deep inspection on traffic that hasn't already been thoroughly vetted, or traffic that falls into higher risk categories. It's a constant balancing act between maximum security and network performance.
Got it. So it opens the letter, reads the contents, and then what?
Then it moves to policy enforcement and threat detection. It enforces the security rules, allowing or blocking the traffic while simultaneously monitoring for insidious threats. For example, it looks for command and control traffic.
Which is when malware on a compromised machine quietly phones home to a hacker's remote server to ask for instructions, right?
Correct. Yeah. Or it looks for data exfiltration, which is an attacker trying to sneak massive amounts of data out of the network.
Oh, right.
And modern solutions are bringing in artificial intelligence and behavioral analytics to spot these anomalies. If Bob from accounting suddenly tries to download 10 terabytes of customer data at 3 in the morning, the AI flags that behavior, even if there isn't a specific manual rule written against it.
And that triggers the final phase, which is automated response. If it sees something bad, it doesn't just send an email to the IT team and wait around for a human to wake up. It can instantly block the traffic, completely isolate the infected workload so the malware can't spread, or lock the user out entirely. All of this happens in milliseconds.
It acts as a dynamic, self-healing defense system.
Listening to this, you might think it only applies to giant tech companies running massive data centers.
Yeah.
But if you work remotely, these virtual firewalls are protecting the cloud-based apps and software as a service platforms you use every single day.
Absolutely.
When you share a file in Microsoft Teams, update a client record in Salesforce, or upload a document to Dropbox, virtual firewalls are the invisible force intercepting, inspecting, and securing that exact data flow. They're guarding your daily digital routine.
It genuinely impacts everyone. And to understand how the industry is maximizing this software-based approach, we have to talk about a massive philosophy shift that's central to our sources today: zero trust.
A zero trust architecture. I hear this buzzword thrown around constantly. What does it actually mean in practice, beyond just being a marketing slogan?
What's fascinating here is the core assumption of zero trust. It flips the old security model entirely upside down. The assumption is simply this: no user, no device, no application, and no workload should ever automatically be trusted, regardless of where they are located.
Yeah.
Just because you have an IP address inside the corporate network doesn't mean you have free reign.
Trust nobody, verify everything, all the time.
Exactly. Virtual firewalls are the primary enforcers of this philosophy. They enforce least privilege access, meaning you only get access to the specific resources you need to do your job and absolutely nothing else. And a key mechanism they use to implement this is microsegmentation.
Microsegmentation. Instead of trusting an entire broad network zone, the security is enforced at the individual workload level. Every single connection between servers or applications has its own independent rules.
Yes.
People usually use a hotel analogy for this, needing a different key card for the lobby, the elevator, your room. But considering we're talking about dynamic cloud environments, I think of it more like a military submarine.
A submarine. I like where this is going.
Think about how a submarine is built with compartmentalized bulkheads. If the hull gets breached in one section, the water starts rushing in. But you don't lose the whole sub.
Right.
That specific compartment's heavy steel doors immediately seal shut. The water is trapped in that one room, preventing the entire submarine from sinking. That's microsegmentation, right? By wrapping a virtual firewall around every single application or server, if an attacker compromises one area, they are locked in that single compartment. They can't move laterally and sink the whole company.
That's a brilliant way to explain it. The mechanism of containing a threat is exactly like those bulkheads sealing shut. And these virtual firewalls carry an extensive tool belt to make sure those doors hold strong.
Like what?
Well, they deploy intrusion prevention systems, web filtering, and VPN security.
And how does a virtual intrusion prevention system, or IPS, actually work better than a physical one?
It comes down to proximity and dynamic scaling. A virtual IPS is constantly looking to block vulnerability attacks. In the old hardware model, you had to route all your traffic back to a central physical hub for inspection, creating a massive bottleneck.
Ooh, that sounds slow.
It was. But a virtual IPS can spin up locally, right next to the compromised workload, instantly. It inspects the traffic right where it lives, add in web filtering to stop users from accessing phishing domains, and heavy-duty VPNs providing encrypted connections for remote workers, and you have a comprehensive shield.
Wow.
They even integrate with global threat intelligence feeds. If a bad actor IP address is identified in Europe, your virtual firewall in North America knows to block it almost instantly.
It's literally like an immune system for the cloud. The benefits here for businesses are massive. The sources highlight rapid deployment. We're talking about spinning up a firewall in minutes instead of waiting weeks for a physical box to be shipped, racked, and cabled.
Yep, time is money.
You get incredible scalability. If your web traffic spikes during a massive holiday sale, your virtual firewalls just automatically scale up with it. Plus, you get the flexibility and cost efficiency of not maintaining giant, power-hungry hardware data centers.
The benefits are undeniable, especially for cloud-native organizations that need to move fast.
Okay, but let me play devil's advocate for a second. We talked about the heavy computational lifting of deep packet inspection.
Mm-hmm.
If this firewall is entirely software-based and it's running on the exact same cloud infrastructure as everything else, doesn't it consume the underlying CPU, the memory, and the network resources that my actual business applications need to function? Like, is there a hidden performance tax here?
If we connect this to the bigger picture, you're hitting on the exact limitations that network architects wrestle with daily. Yes, there is a resource dependency. The virtual firewall consumes CPU and memory. In ultra-high-speed environments, think financial trading platforms where stock trades happen in microseconds, pure software might introduce too much latency. Those specific high-frequency environments often still require dedicated resources or specialized hardware acceleration to keep up with the sheer volume of packets.
So it's not a perfect silver bullet for every single scenario on Earth.
No, it isn't. Furthermore, managing the policies across thousands of virtual firewalls in a large multi-cloud environment is highly complex. And we really have to remember the cloud responsibility model.
Oh, this is crucial. Can you break that down for us?
Gladly. When you use Amazon Web Services or Microsoft Azure, they secure the underlying physical data center. They make sure nobody physically breaks into the building and steals the server rack.
Right.
But the organization, not the cloud provider, is entirely responsible for configuring the security in the cloud, including these virtual firewalls. If you accidentally misconfigure a policy and leave a virtual port wide open to the internet, that is on you, and you will get breached. The cloud provider won't save you.
So the cloud provider gives you the locks, but you have to remember to actually lock the door.
Exactly. It requires a highly skilled security team to manage it all without accidentally breaking the applications in the process.
Which brings us to the horizon. Where is all of this going? As everything gets more complicated and workloads spin up and down by the second and everything becomes API-driven, meaning software programs are just directly talking to other software programs constantly, what's next for virtual firewalls?
The sources make it very clear the future relies heavily on artificial intelligence.
Of course it does.
The sheer volume of traffic and the incredible speed of cloud environments are rapidly surpassing human capacity to manually write and update rules. Very soon, AI will automatically generate security policies on the fly based on what the application needs in that exact millisecond.
That's wild.
It is. It will detect abnormal behavior in real time, predict attacks before they fully materialize, and respond autonomously to isolate threats without a human ever needing to intervene.
So what does this all mean? It means that as we move deeper into this elastic, constantly shifting digital world, our security has to be just as shape-shifting and automated as the infrastructure it protects. The days of static defense are totally over. We are entering an era of living, breathing, software-defined guardians.
That's the reality we're operating in. The architecture has fundamentally transformed to meet the moment.
Well, you've been listening to the WeCyberYou Unlocked podcast, and I want to thank you so much for joining us on this journey today. We've moved from clunky metal hardware boxes and bouncers at the door to these intelligent, invisible guardians of the cloud using submarine bulkheads to stop lateral threats. It is a truly fascinating evolution. Remember to hit that follow button, and please head over to WeCyberYou.com for more deep dives that unpack the technology shaping our world.
We noted that the future of virtual firewalls is using AI to automatically predict attacks and generate security policies. But it raises a profound question to leave you with. If our virtual firewalls are using AI to instantly adapt to threats, how long until attackers deploy their own AI to dynamically rewrite their malware in real time, specifically designed to bypass the very policies our AI just created? Are we securing our clouds or just setting the stage for an infinite loop of machine versus machine warfare?
Wow, that is a heavy thought to chew on. Machine versus machine. Thank you again for your time, everyone. Stay safe out there in the digital wild, and we will catch you on the next deep dive.